Welcome again to the Southwest Climate Podcast, the longest running podcast on climate and weather in the Southwest of the United States. Mike Crimmins.
Hey, Zach, I do it.
I don't think that's actually a compliment.
It's like the world's largest ball of twine.
I sense you're kind of persnickety. So how you doing? How you feeling? How's your monsoon mood meter treating you?
It's not good, Zach. It's not good, which is really weird for the way this monsoon has been rolling across the Southwest. So you can probably guess why.
How much has rained at your house?
So we've had about a half inch.
So I should mention that we are recording this at the tail end of July. So this is Thursday, July 28th. You have had a half an inch with an early start that we'll talk about and through 90% of July.
That's right. Yeah. And how about you?
Less.
I know. You're in much better mood than I am.
I'm actually not. I'm not recording at my house, but there is like a Pima County flood control gauge, like 3 blocks from my house. So at that station, and I live close to downtown, it's 0.28, basically a quarter of an inch of rain to date through the monsoon season, which honestly is pretty depressing. But you look out, Mike, and you're like, I've had a number of big thunder claps and I'm like, it's on, and then nothing.
I'm with you, man. It's been a phenomenal spectator sport this summer. And I'm trying to decide, like, emotionally, is it better to just have everybody go down together like 2020, where we're all in misery? Or is it better to actually have some people get some rain, even if it's not me? You can kind of see this is like a moral dilemma.
I think it's a lot like if you're watching sports and your favorite team loses in overtime. I think this year is like losing in overtime versus if you just get blown out.
Yeah, that's right. Because you have that heightened adrenaline and you're so invested. I was remembering watching some soccer in the spring where you watch a team go down in overtime, and those games are just so emotionally exhausting, whereas the ones that are over at the beginning are kind of boring. I think that's really good because 2020, I had deep resignation by this time, right? We were both just like, let's just move on. Whereas
you go through the full stages of grief. We talked about this. But
totally
you can progress. You can progress.
Yeah, and I even understand, like, my livelihood doesn't depend on it raining. So I can only imagine what it's like if you're like a farmer or a rancher or dealing with, management issues, wildlife and ecosystems where you need this rain. It's just like I'm so invested in it raining at our house that I get completely emotionally tangled up in it. Whereas I was standing outside several afternoons this week watching the clouds. We don't do that much, but I was actually literally watching the clouds, like looking to see if that storm complex was going to make it close to our neighborhood and if that one was going to come over here and that kind of stuff. And I could not believe on how unlucky we were. And day after day after day, where it would rain so close to our house, like an inch, and we wouldn't even get the sloppy drops that would fly out of the edge of the storm or any of that kind of stuff. So, I mean, it's been a little bit intense that way.
Yeah, your Slack messages have mirrored what happened a couple of years ago. They've been angry.
They haven't, and it's nuts because
is how I would describe it. You've been a little moody.
Oh, and I have. I was telling you earlier too that I've been a little bit short with my family members, and I was trying to figure out why, and I realized it was because of the rain. And I'm like, that is not healthy. That is not a good way. And like you said, I just watched an epic thunderstorm pound the west end of the Catalinas for the 6th day in a row, and it was beautiful. But I couldn't even conjure up the just feeling good for those people getting that rain.
All right. So I tagged us with a little bit of a thought experiment to push us here, which is we're going to frame this podcast around for making a case that it's been a good monsoon and making a case that it's been a bad monsoon. So that's what you're going to get. We'll also do a little bit of a segment on some of the hazards, and we'll end it with the Monsoon Fantasy Forecasting Game, which is in its second version this year, and it's even more popular than last year, and we're having a lot of fun with it. So we'll talk to those.
You could have won a home weather station to track your precip at home, Zach.
No, last year. This year, fortunately, we have a better gift, or a gift that will resonate with more of our players, which is just an Amazon gift card. All right. So before getting into that, just a little bit of housekeeping. What we wanted to do is try to get a sense of who's listening and what they find valuable about this podcast. Because inevitably, at some point, Mike, somebody asks, why are you doing this? And why are you not doing that? I mean, I know why I'm doing this. This is like the best day of my month.
Same here. Yep.
But that doesn't always resonate with the people that want you to do other things too. So we've got to, we just kind of want to see who's listening. And so if you have been listening, or even if you're just tuning into this podcast for the first time, it'd be great. We'd be really appreciative if you just fill out a short survey, probably take you 5 minutes.
Yeah, very short.
We'll paste that link in the show notes, but for those that are just tuning in, listening to this, I'll read it out. It's tinyurl.com/SW Climate Pod. So we'll post that also in the show notes. Ben sends out an email, so it'll be in that email as well. But if you're not part of the Clemis listserv and you don't get the email and you just have this coming directly to you via whatever podcast server you use, then it'll be in the show notes. But so tell us what you think. Just a couple questions. Love to hear from you. Other thing I want to mention is we've been getting a few really good questions. People just send us emails. If you are inclined to do so, we'd love to take them. We try to weave them in. If not explicitly mention what the questions are, we'll try to weave it in and answer it implicitly, and we'll do that today. Hopefully, good question around mesoscale convective systems. So
thanks, Sarah. And there's no guarantee that we'll actually give a right answer or a good answer or any combination of,
or a coherent answer. But we'll try.
We will try.
All right. So Mike, our last podcast was right before the monsoon season, quote unquote, officially began June 15th. And all of the talk was for an early onset. There was some indication, maybe some mixed actually results or hints at it. But I do remember the chatter was about the moisture was going to creep in a little bit early. And there was a lot of excitement about that. And that actually played out. And so we did have an early onset of the monsoon if you want to use the old sort of dew point definition. Otherwise, it starts at the same time every single year. But what fun is that? So we're gonna use the old dew point definitions at Tucson, which is dew point values for 3 consecutive days above 54 degrees Fahrenheit. Right. And if you use that metric for Tucson, it turns out that the moisture sort of wafted into the region 7th earliest on record.
Yeah, really, pretty impressive. Yeah.
Yeah. And that third day would have been on June 23rd. Okay. So a full week before, maybe even a full 10 days before historically the monsoon starts in Tucson. And in Phoenix, that they have a very similar dew point definition. It's a degree higher, but their third consecutive day would have been the 8th earliest on record and June 27th. So for June, then if you just look at the aerial sort of spatial average across the Southwest monsoon region, I'm now looking at your figure, Mike, which looks at the percent of the area experiencing different categories of rain. So either much above average for that particular time, or above average or near average or below average, right? So basically at its height, at the end of June, we had close to 50% of the Southwest experiencing much above average at that point. So, I mean, those values, right, they're small, right? So the values aren't that big, but it is an indication that I was talking about Tucson and Phoenix, but there was activity. There was activity, and it was fairly widespread. I mean, again, not just much above average, but if you look at near average, above average, and much above average, your 3 categories, it was close to 75%, a little bit over 75% of the Southwest monsoon region, based on this PRISM data. So what the heck was going on in June?
the forecasts at that point were pretty bullish on us having kind of a good, decent setup, kind of the way we're anticipating the monsoon last summer. And I was a bit skeptical that we're going to end up having some kind of repeat. Moisture-wise, it was pretty good. There was more of this trough off of the West Coast, building subtropical ridge, building monsoon ridge to the south, which by the middle part of June got in the right position and started to push the moisture up into the southwest, which doesn't happen necessarily every year. We can end up having that trough push a little bit further south and dry us out, scour us out, and even cool the temperatures down a little bit, or we can end up having the ridge just in the wrong spot where that moisture import isn't there. So it was about June 18th into the 19th, you started to see this plume of moisture really reach up into New Mexico. And so New Mexico ended up having the activity first. And they ended up having a really gangbuster set of days on the 18th, like the 19th, the 20th, 21st, a big day on the 22nd, some pretty heavy rain across much of western New Mexico. I think it even reached up close to Albuquerque. That pattern, lasted for like 6 or 7 days. And so I think that that's where you saw the big run up in the aerial coverage of the above average anomalies at that point. But largely, sort of from Phoenix west, there wasn't much activity. So, but by the end of the month, just as you noted with the dew point, those dew points did creep up in the Tucson and Phoenix areas and started to fill in the low deserts. And we did start to see some activity that did put down some pretty good precipitation, like on the 26th, the 27th. It did sort of slop back into New Mexico on the 28th. And that was the pretty robust start to the monsoon in that June period.
Yeah, so looking at the preset maps, you noted that June 22nd, sort of widespread across New Mexico, and it was in part maybe just a little bit on the southeastern side of Arizona.
Yeah.
Do you recall that event? Because if you look at all of the monsoon days to date, that is the day that has the most widespread rain, and it looks like the most intense or whatever amount of rain that fell was on that day.
I believe it was a trough kind of interacting with subtropical moisture. So that's typically what we see that drives these really kind of widespread heavy rain events and they tend to occur at the beginning of the season and the end of the season. And you end up needing to have the dynamics and the moisture kind of interacting with each other to get wide-scale heavy rainfall.
Yeah, and again, looking at another sort of metric of an early onset. So sort of looking at in Arizona, it's the percent of area that experienced rain. The average through June is, less than 5%. And basically every single day was over that average, and the same for New Mexico. And then if you zoom further out into July, I mean, maybe this is the beginning of the case for the good monsoon, right? Like that it quite literally has been raining a little bit at the very least. The aerial coverage of rainfall has been above average for almost every single day, maybe with the exception of 3 or 4 days, from this July, 27th, looking at yesterday, from yesterday to the start of the monsoon, June 15th. So, I mean, again, we're thinking a little bit more about not just June, but into July. But I do think maybe the story has been quite different than we started this pod with. If you just don't live close to us.
Yeah. There's been, it's such a weird monsoon so far, which is I don't know, like I'm sure if we dug back through the records, which we actually tried to do to try to find an analog, a similar year, they're all just different from enough from each other that they don't match. And so our effort today is to try to like point out what some of the nuances are. The kind of the evolution of the timing of the monsoon was that pretty busy period, the end of June. It actually did slow down quite dramatically where you got into the first week of July. And it wasn't even really until you got to I don't know, around the 15th of this month, where the activity started to expand across the region again and pick back up. And, before that, it was pretty isolated in kind of low grade activity. So we've had a couple, what we call sort of burst periods, a pretty long break period in the middle of July. And we're now a burst period more recently that has dropped some very isolated, very heavy rain, causing flash flooding. And especially what's been most impactful in areas like Flagstaff, where that rain is falling on burn scars, and you're seeing just crazy flash flooding with debris flows and large-scale geomorphic change. But these have not been big, widespread, organized thunderstorm complexes that have swept across, entire counties, have traversed, into the low deserts. They've been very slow moving, if maybe not moving at all, storms that have favored some topographically, some, higher elevation locations, with some of those areas nearby benefiting as well.
So I want to pause on that analog year, because I actually tried to do this exercise too, right? I was just looking at June, and I looked at the years where there was an early onset and tried to find a similar pattern. 2000, which was the earliest onset in Tucson, if you use that old definition, was very similar in terms of dew point. It had a lot more rain, however, in June than it did this year. But I was, rain can be a fickle thing at particularly one station. So I was trying not to use just that metric. I don't know. What do you think of 2000? Did that jump out to you at all? Or
yeah, I'm looking at the anomaly coverage time series that we were just talking about, and it has that sort of similar, really, quick ramp up, and it decayed really quickly, right? Like that pacing of it just could not keep up. It looks like we're doing better this year than we did in 2000. So I think in 2000, you saw that June activity give way to a really quiet July, some activity in middle of August, and that was it. And then that monsoon was basically over by August 31st. The prism maps for the whole region, just using that 2000 analog, thinking about it in terms of like the equivalent gridded precip data for right now. I don't know, man. It's like,
so what sticks out to you as you said it's weird?
We carved it up in a couple of acts already, right? We've got that pretty robust start, especially favoring New Mexico. That's, New Mexico coming online first, reaching into Southwest New Mexico and Southeast Arizona. That's the normal progression of the monsoon. So that really wasn't unusual. The monsoon moisture
2 weeks earlier, though, or
2 weeks earlier.
earlier.
Absolutely. Yeah. That is unusual. You're totally right. So that was, really encouraging. And it seemed to like it bore out in the forecast. Maybe there's a little bit of that La Nina correlation that's part of this as well. So all that kind of playing together. The break in the early part of July, very hot temperatures, humidity was up, not a lot of rainfall, was a little bit dismaying, because that was pretty different than we saw last summer with that really robust. If you're thinking, and I think part of my problem is that I have this sort of like recency bias, where like the last monsoon I can remember is the one that I expect to happen again. They never work that way, right? And this one's completely different than that, right? This long break period. This more recent period has definitely deep moisture, lots of precipitable water across the region, daily rounds of thunderstorms. It's been cloudy in the afternoon at our house every day for 6 days now. So it feels like a busy, active monsoon, but the precip patterns have been parked largely. And we haven't had much organization in the storms. And so they're not really sort of dousing, whole watersheds and, kind of spreading out that precipitation. So, but that could change at any point now, as things reorganize. It's just been a very persistent, stagnant pattern for about 10 days now here.
We've had moisture.
Oh, absolutely. Yeah.
There's been a lot of moisture.
A lot of moisture. Yep. Yep.
And there was a lot of moisture last year. And last year in July, if people remember, and I honestly don't know how you could forget, 8 inches just at the airport, but very, very vigorous July across the Southwest. So like, what's the difference?
So precipitable water, it's a column integrated measure of moisture in the atmosphere, right? So it's like if you took a column of moisture from the surface up into the atmosphere, and you wrung it out, you try to squeeze out all that water, that depth is the amount of water in the atmosphere. And it's a nice integrated measure of moisture. And most of the moisture is at the surface, and it decreases as you go up in height. So it integrates over that.
What's that value in June?
Well, again, it changes. So lower elevations have more atmosphere, so they can be higher precipitable waters, right? And so you go to the top of a mountain, you should have lower. So there's already sort of a climatology with that. But yeah, in June, it's like a half inch, a quarter inch.
I would have thought it was a bit even less. Sorry, I was trying to make it.
It absolutely can be. I think I was leaning towards the middle of the month, right?
Yeah.
And it's like, as you get to about 1 inch precipitable water, you start to get kind of excited that you've got enough moisture to start to support storm development, right? And so at about 1 inch, you can get storms to form, but they'll typically be pretty high based. It's those June storms, right? You can see them for 100 miles, and they're the photogenic ones, Zach, that you can take great pictures of, because there's not much around the storms. They're real high based. You can see all the column of rain come out of it. Often they'll produce a lot of wind. So you get up to like 1.5, you're into the game, and that's much deeper moisture. We've been up Tucson like 1.8, and 2 inches is now like, when you get to 2, you're at record levels typically, depending on the location here in the Southwest. So 1.5 to 1.8, plenty. That's totally plenty of moisture. And when you get into those situations where you have that much moisture, the sun doesn't have to do much work to actually create a thunderstorm anymore. It just has to rise in the morning, and all of a sudden you've got storms firing up, which is this July 28th is exactly what happened this morning.
Was the precipitable water, though, has it been markedly different or very similar to last year? July was gangbusters last year, and there was a lot of moisture around. There was a lot of rain. This year, there's been a lot of moisture around, and just, it seems like in some key places, including at your and my houses, there hasn't been that rain. So we can't really point to the fact that the moisture has been an issue with generating widespread, and so it's not the moisture. You're shaking your head.
We've got these pretty coarse gridded data sets from climate models that try to basically fill in all the surface observations. So looking at precipitable water observations for June 15th through July 26th of last year, there's this real strong bullseye of about 10 millimeters more than you'd expect over the northern Gulf of California. And that extended well up into much of Arizona and into New Mexico. This year, the pattern is really similar. It's just not quite as extreme. It's like 6 to 8 millimeters above average. So it looks really good, from a precipitable water moisture standpoint. And, that suggests that the overall synoptic pattern has been really favorable to have Gulf surge events and import moisture on easterly flow. So yeah, everything is totally in the right spot flow-wise to have that key ingredient for a good monsoon, which is moisture.
Let me just go over what the pattern of precipitation has been from June 15th through the 27th of July. And then maybe you can make the case for why you could argue it's a bad monsoon. And then I'll make the case for maybe why you can think of it as a good monsoon. All right. So the pattern is above average rainfall has basically fallen in Arizona from the Mogollon Rim, the northeast quadrant of Arizona, from Show Low to Flagstaff to the Grand Canyon, all the way up to the Four Corners. Now, admittedly, there isn't a lot of good data coverage in the far Four Corner region, but if you look at the map, this PRISM data set is showing sort of above average rainfall at the higher elevations. Also above average rainfall, far southeastern corner, Sierra Vista, Douglas, Safford area, and south and west of Phoenix. So a good portion, like eyeballing it here, like 50% of Arizona with above average rainfall, and there's been some notable dry areas. Kingman also has seen in that area above average rainfall. The notable areas of dry, funny, it's been right around Tucson.
Not all of Tucson, though.
Not all of Tucson. No. I'm broad brush here.
Yeah.
South and west of Tucson, around the border region, far southwestern area, Yuma area, the northeastern corner, a little bit north of Prescott and west of Flagstaff, and then north and east of Phoenix. So there's been some large regions of above average and more isolated regions sort of pocketed of below average across Arizona. And then if you go to New Mexico, it's a little bit easier to describe. The eastern sliver of eastern Arizona has been below average rainfall, and basically from central New Mexico to the border region, north to south, has been above average rainfall. In fact, the sort of highest values in New Mexico have been sort of in central western New Mexico, and largely, Mike, that it looks like that maps on quite favorably to more or less that one major event in 22nd of June. It looks like that probably is driving the New Mexico pattern, at least in the western half of New Mexico.
Yeah, I think that's right. They've also, so the Gila Mountains have had very frequent afternoon thunderstorms as well. So they not only had that, but they've had, this extends all the way into the eastern mountains of Arizona too. So Mogollon Rim extending to the Gila Mountains, that area is just like every day it's been raining, so like the percentage of days with rain in those parts of New Mexico is greater than 80% of days since June 15th.
Right. And I think this is an argument for why it's been a good monsoon. If you look at the higher elevations, the distribution, I mean, a lot of the higher elevations are experiencing above average rainfall to date. It's the low deserts, the lower elevations, particularly around like between the 2,000 and 4,000 feet elevation range, like where Tucson is. That's been the area that struggled the most. So with that pattern, Mike, make a case for me why you think it's been, or not why you think, but why one could argue, because I have heard, a lot of people have come up to me and been like, what's going on with the monsoon? And so there's quite a number of people that it's not raining at their house, just like it isn't at our house. But what could be driving that argument that it just hasn't been a great monsoon?
I think the spatial coverage of the storms it's been favoring certain locations over and over again because of the really, really weak flow pattern, right? So lots of moisture. We've had some very weak organizing mechanisms in the form of mesoscale convective vortices, which is maybe a segue to talking about those a little bit more. But overall, this idea of a weak flow pattern, so not having much wind directional shear or speed shear, well, we need the speed shear in particular, meaning having, as you go up in the atmosphere, having some winds that would actually cause the morning thunderstorms that will always form first on the mountains, typically, be moved off into the lower desert locations, right? And if there's enough of that change up in the flow pattern over how many days has it been in the monsoon since the 15th? So like 40 or 50 days, what you'll start to do is you'll get, with all this moisture, rounds of thunderstorms, and they'll paint a stripe on one spot one day, they'll paint a stripe on a different spot the next day, maybe the next day that'll go back to that first spot, but you'll start to get more of an even precipitation pattern. But with this really weak flow, you end up having this repeat pattern over and over again. And so you can start to see locations like even in Tucson and just real small areas will get the same heavy rain days and days and days on end, whereas just 10 miles away, there's
and those are closer to the mountains.
Yeah. But I'm even looking at, there's a monsoon rainfall update that the Flagstaff Weather Service office just posted, and I was really intrigued by seeing that Payson, which is way up in the mountains in the high country of eastern Arizona, they've had just less than an inch, and they would normally see about 2.51 inches today. So they're about an inch and a half behind. And the Heber Ranger Station, which is not that far from Payson, has actually had 5.5 inches of rain, which is 3 inches above, right? So those are two higher elevation locations that are completely in different monsoon season precipitation totals to date. And so it's you hope with a monsoon season that you have enough of a shakeup over time that you start to even the spatial pattern of precipitation out so that benefit is kind of spread around. Because honestly, not getting monsoon moisture it's impactful, especially coming off of, 2 La Nina winters and this past La Nina winter. So we'll start to see pretty dramatic drought impacts at these locations that aren't getting the monsoon moisture, and staring down the potential of a third La Nina winter. We need this spatial pattern to kind of even out and spread the love around a little bit here.
So the key thing then is the winds. I mean, the moisture's been there. I mean, this is one maybe thing that you can read into the percent of precipitation by altitude. It's like where there is the ability of where you don't need wind as much to sort of drive storms into the low desert. In other words, like where you have topography and the topography can create that its own uplift. The presence of the moisture generates rain, but you got to move those storms off the higher elevations. And if you just don't have that steering flow, then it's just not going to happen. Or where those storms do fire up, they don't move quite as far. Yeah,
and it's been a little bit frustrating to watch. This is just because I'm so emotionally invested in it, right? Is that it's, Casa Grande, which is a lower desert location, it's lower elevation than Tucson, has had several rounds of thunderstorms that have been able to fire up. And, even places like Eloy, which is along Interstate I-10 on the way to Phoenix, south of Casa Grande, have seen some pretty intense rainfall events that have occurred. So I think that they had the right thermodynamics for the right situation. Part of what's happened in being real close proximity in some of these valley locations like Tucson is that we've had all the right ingredients, but ended up having the storms form on the mountains, and then the anvils will shade out the valley, and then you're basically out of the game at that point because your thermodynamics are not going to work. Whereas some of those lower desert locations, they're able to bake in the sun, become thermodynamically unstable, and then they get a nice outflow from the storms forming northwest of Tucson, and that's enough to kick up the storms there. So it ends up happening repeatedly because the overall flow pattern is just subtly enough the same from the previous day that you can get the sort of recurrent places where this precipitation is occurring. And Phoenix has suffered from this too. They've had a couple of storms pop up across the valley, but and they even had a wind event related to a microburst earlier this month from some organization of storms. But I think that was the only time that really occurred. And then, even watching the storms form today, the map across Arizona is just painted with flash flood warnings because of some of these locations just getting socked in with rain day after day. And so, the additional rainfall the next day is just enough to trigger those flash floods.
So the anvil comment's an interesting one. Admittedly, I've been gone for a fair amount this summer, so I haven't been present to actually observe things. And sometimes you just can't get the feel when you're not here, even if you've got a whole bunch of maps and data to look at. But anecdotally, I have noticed that it feels like there's been less evening, late afternoon, early evening, even night kinds of events. Like there hasn't been the sort of easterly waves, or the way that I usually think about it, there's a couple different mechanisms that can generate these storms. There's obviously the solar one that you get really hot conditions that can drive the convective storm. So clear skies in the morning. And then, if you have moisture around, you see those clouds build and they're ready to burst. And so that convective solar generated mechanism is critical. But then there's also those events, and this happened last year, where there's just rain at night. And that you need something moving in that creates that generates that uplift, creates the favorable dynamics. And so have those kinds of conditions been less frequent this year or not? I mean, I'm thinking easterly waves and those kinds of things that can come in.
Since June 15th, it has constantly evolved, right? This season has constantly evolved, as you'd expect any season to do. We're just in a phase right now, the end of July, that is it's not that unusual for this time of year. It's just a little frustrating if you're wanting it to rain at your house. It's raining at a lot of other people's houses, which is great. And it's raining in areas that really need the rainfall. So totally cool with that. So so that pattern early in the month, it was really very low activity, downgrade activity, giving way to more moisture and some better activity. The easterly waves have been certainly discussed in the discussions, and I think we've seen evidence of that coming across from the position of the big subtropical ridge and the easterly flow that we've been in, have come across from New Mexico, and it's really been over northern Mexico. And northern Mexico has seen several of these large-scale, mesoscale convective complexes form. Those are where you can get afternoon thunderstorms turn into clusters of thunderstorms, and those clusters of thunderstorms actually merge together and become a giant kind of coherent kind of breathing monster of storms that will move along on the easterly flow. And if they can cross into the Gulf of California, that's actually one of the triggers of Gulf surges. And so we've had a fairly frequent number of Gulf surges over the last couple of weeks, which is why the moisture has been so good in Arizona, right? So that's all kind of worked out together, and that's been really, really favorable. The flow over especially the last 10 days has been extremely weak in diffuse, and because of the high pressure system across the west it's sprawling. It's Mike Luthel was talking in this discussion, it's basically flat, right? So you think about a kind of a topographic map, we look at these height features to give us an indication of where there's going to be circulation patterns, and it's been largely flat across much of that. So that's not going to give you any kind of shear. It's actually not going to be real helpful for steering easterly waves in either, because there's no real flow with it as well. So what we'll need to see happen is we'll need to see some reorganization of the overall bigger synoptic pattern, and that what could happen is that you can end up in these sort of break. Well, this isn't a break period because it's got all this moisture, but the high can rebuild in a kind of a hotter spot of the west. We'll start to get some height field rebuild, and then you'll start to see the flow reorganize around it. And so if we can hang on to the moisture, the dynamics may become more favorable for more organization coming into August. And the forecasts seem to suggest that that's still possible.
So I want to go back because sometimes I get lost in the terminology. And
sure.
The MCSs, the mesoscale convective systems, you can look that up, and you can also find mesoscale convective complexes, mesoscale convective vortices, right? So let me see if I can explain this or explain what I think they are, Mike, and you can correct me when I'm wrong. But these are important things, particularly in northern Mexico, right? Like if they're important everywhere, but they seem, if they happen in northern Mexico, they, as you said, they help trigger surges of moisture up into our region. So they're one of the mechanisms that can help drive moisture and generate part of the conditions that are favorable for monsoon. And so how I see these things it's just sort of a large hundreds or 100 kilometers. They have a particular spatial definition, but we're talking like 100 kilometers across its large axis of thunderstorms so these are widespread events, right? The coverage is pretty large, a lot of thunderstorm activities, but they sort of organize into some sort of coherence where they can generate their own sort of flow.
Yeah.
Right? And that flow can be circular, but it doesn't actually have to. They can be these linear features as well. And you slacked me a 1990 paper had a couple authors, and I just remember Bob Maddox being one of them. I tried to read it, couldn't wrap my head around it. But one of the things that I did learn is that these mesoscale convective complexes or systems can be things like a squall line or a derecho, but they can also be the hurricanes, and tropical cyclones are defined as them as well. And in our case, it's sort of like the combination of a bunch of convective cells together that then come together and can produce their own sort of flow. And one of the things that they generate is these mesoscale convective vortices, which are within these complexes. This is where the lingo gets like really sort of nuancy, right? But those vortices are just these spinning centers that can actually then subsequently generate other storms. So they can last for quite a bit of time and sort of meander around the area. And in that way, they have a longer life than just sort of a one thunderstorm or a few cells that are popping off in any particular day. So what did I do wrong there?
No, you're spot on. I think we can think of this really simply in terms of what you just said, which is if you can have a thunderstorm event where you can get a bunch of smaller thunderstorms to sort of be close to each other, and they start to grow in size, where they start to then kind of form a large cluster of thunderstorms. You have all of this rising air, all of this huge release of heat, because as you have all that rising air, you're going to have tons of condensation. Condensation releases energy up to the middle levels of the atmosphere. That's one of the functions of them thermodynamically. And you're going to end up having all of this rainfall out of it and this large cold pool that's underneath it, right? So that becomes a large coherent anomaly or disturbance kind of in the atmospheric field. And so all of that extra heating of the middle levels of the atmosphere, this organized thunderstorm complex, induces a change in we call potential vorticity, which then induces a spin. And so the long duration of these organized thunderstorm clusters becomes critical, because the time aspect of it and the size aspect of it leads to the ability for this small amount of spin, the vortex, to actually form after the thunderstorm decay. And so what it does is it, just as you said, leaves behind these little spinning vortices. And again, you got to remember too, this is occurring in very weak flow, right? So as you talked about, like squall lines or derechos, which happen up in the here in the U.S., they'll happen up in the Great Plains and in the Midwest, where you've got the dynamics of like cold fronts and larger sort of air mass interactions. Here, this is all occurring in a maritime tropical air mass. And so it's then just completely a function of the shape and size of these thunderstorm complexes. And what it leaves behind is this little warm core circulation that looks like a little tiny hurricane on a satellite image. So they're really fascinating. Mike Luthold talked about it on his discussion. It's been in the Weather Service discussions. Others have noted, if you looked at the satellite images for the last week, we've had a bunch of tiny little, these swirls that if you watch the swirls in the morning, they're evident, and you'll start to see bands of thunderstorms that can form on the edges of these mesoscale vortices. I watched one yesterday. It was so cool. It was this thunderstorm that exploded out of the center of this MCV, mesoscale convective vortex, over northern Arizona. I mean, it was just like, it looked like a hurricane eye wall popping off at that point. It wasn't the same by any means, but it was, again, that little bit of shear and the little bit of dynamics that these MCVs provide can be a focusing mechanism to enhance both lift and shear in these situations.
That was much deeper than I went. Appreciate that.
It's all right.
I'm not sure you were that convincing with the argument for it's been a bad monsoon.
I'm not sure it has been either. Like, yeah. I think I'm not convincing because I don't think it's been.
I gave you the harder one because I mean, I do think like we're sort of around Tucson, and like, again, if you look at that map, like it's kind of been, Tucson's been in terms of population, where the population centers are, it's probably fared the worst. Maybe northeastern Phoenix has also not fared as well, but our neighborhood, and not all of it, like you said, our neighborhoods have suffered. I mean, for the Tucson airport, you have to go back to the early 1990s to have a lower rainfall total at this date.
That's amazing, isn't it?
Yeah.
And we were looking at the flood control gauges, and just a mile north or south of the airport, the precip is double.
Yeah. We should note, though, that even if it's doubled, or even in places that it's doubled,
right, it's still
below average.
Yeah.
It's still below average.
Right. If you look across the Tucson Basin, though, I was trying to use that kind of thinking here too, like monsoon to date. What should Tucson have today? About 2
something like that.
Yeah. Something like that. Okay. So if you I'm looking at the rain log observations across Tucson. I mean, I can't really query it this way, but probably a third of the rain loggers in Tucson have met that. There's probably 2/3 are below that, but it ranges pretty dramatically of how far below. I mean, I'm just again, we've seen this before. This is not unprecedented, but just like the precip patterns along the foothills of the Catalina Mountains here in Tucson. And I think you could tell this story all the way in different locations across the Southwest, where there are places along the front range of the Catalinas that have had about a half inch to a third inch to 5 inches, and only 5-6 miles apart from each other. I mean, it's the monsoon, but man, let's shake it up a little bit here.
I think we've actually already made the case for why one should consider this not a bad monsoon, but let me just review that, right? There's been moisture around. So the fact that it hasn't rained in some places has been a function of such things that you mentioned before, which is like the wind profiles just haven't been conducive for widespread rainfall, but it's rained in the high country.
Yeah, and even in the low country. I mean,
in the low country,
there've been a handful of events that have pushed all the way out into western Arizona. Not handfuls too many, like a couple, right? And those areas oftentimes will only see 1 or 2 events the whole summer. So the real deep negative anomalies they're really kind of pockmarked and spread haphazardly across the Southwest right now.
Other cases for a good monsoon, like northern Arizona, a lot of the population centers have fared fairly well. Flagstaff's above average. Kingman is just slightly above average. Page is above average. Prescott's just slightly below average. Show Low's much above average. Winslow's above average. In southeastern Arizona, Nogales is above average. Safford's above average. Sierra Vista's above average. Ajo's above average. And it's a mixed bag when you look at Tucson. Obviously, it's below. Wilcox is below, and Picacho Peak areas is below. So a little bit more of a mixed bag in southeastern Arizona. What else?
How's New Mexico doing?
Yeah, and New Mexico has been most of New Mexico has been above average, and we already talked about Gila, the high areas. Northern Mexico, the heart of the monsoon region. It's been so. Sorry, Tucson. Sorry, Mike.
It seems to be you and I. I mean, it's like, I think even Ben's house has had more rain than our total combined. Yeah, it's bad luck at that point. I think I'm digging myself out of this slump. I think it could change, and I think it could change really quickly.
You just need to go hiking and on the Santa Catalinas, or go up to like Payson or Flagstaff.
I hate driving to my rainfall, Zach. It's just like,
fair enough.
I want it to come to me.
All right, Mike, very quickly, just a little bit about the hazards. I think heat is a little bit, it's worth dwelling a little bit on the temperatures. Through July 27th, the heat ranks for the major cities have all top 10 with the exception of Flagstaff. So El Paso's, its maximum temperature, its average maximum temperature has been the 6th hottest on its record. Albuquerque, top 20. Tucson is currently ranking at 7th, so it's in the top 10. Flagstaff, right around its midpoint, it's 47th. I was actually a little bit surprised, to be honest, because there's been quite a bit of cloud cover. I will say that the minimum temperatures, the anomalies have been warmer than the maximum temperatures have.
The temps for the month were really driven by the break we had at the early part, and it's only been in the last week or so that we've started to have the afternoon cloud cover and the moderation of the temperatures, but it's not before you're starting to get some, decent pushes in the afternoon temps. But yeah, the cloud cover has been a little bit more recent than the rest of the month.
I was surprised though when I looked at the number of days, and this is courtesy of Paul Inez at the National Weather Service in Phoenix. I was surprised to see how many days in Tucson were above 100 degrees. And right now, we're above average, and it's the 6th highest number of days through the date on record.
Wow.
Yeah, we've had 51.
Wow.
We've had 51. And the highest total through this date was 58. And that was 2020 had 57, 1988 had 58. So we're above average, and we're in the top 10.
Even with all this moisture and cloud cover around, it's pretty impressive.
Yeah, Phoenix is also running above average. To date, it's had 65 days, 100 degrees Fahrenheit or above. It's not in the top 10. which is not surprising. And 2020 was like Tucson, had the second most through this date, which was 74. And 1989 had the most, 79. So
wow.
2 weeks fewer days above 100 from the record in Phoenix. Anything else? Anything strike you about temperature that you want to go over? I mean, it's a similar story. The trends are all trending above average. So.
Yeah, I mean, the climate change signal is definitely here. It's baked into all of these statistics. And again, I was surprised, Tom Ben earlier too, as I pulled up the temperature map for the last 30 days, thinking it was going to be a bit more moderate than it was, given the moisture that's been around. But that's what we're dealing with now.
I didn't get a chance to look at fire, and I meant to. I just ran out of time. I don't know if you have any, we're past the peak. Obviously, fire activity ramps down during the monsoon season. There's still some here and there, but for the most part, where we come in terms of statistics, yearly statistics is sort of set in stone.
There were some impactful fires, including the Hermit Peak Calf Canyon complex in New Mexico, which is either the largest or the second largest on record. Anyways, the monsoon onset was really, really critical to taking that season and trying to put it to bed. And I think it largely did. I think the monsoon moisture coming in June was really critical. And 2 weeks ahead of schedule, 2 weeks can make a huge difference on the spread. There has been some fires that have continued to pop up due to lightning, but have been fairly small and I think contained pretty quickly, at least what I've seen in Arizona over the last couple of weeks.
All right. So in real time, Ben is slacking us. So we have some statistics. Yeah. Now I'm remembering this. New Mexico, I think, it's first and second largest fire on record this year. So its total number of acres burned, we're north of 600,000, and its average is around 100 and a quarter. So 125,000. So much above average. Arizona, on the other hand, and this is through actually just July 5th, but again, it's probably most of the story there. So Arizona was right around average for the year. So New Mexico was driven in large part by those two fires. Okay, so through July 19, New Mexico 850,000, a little bit more than 850,000 acres burned, and Arizona a little bit more than 82,000. So there you have the statistics. Arizona close to average, New Mexico way above average. Drought, Mike, anything you want to mention about drought? I mean, this is the time, obviously, where, the places that it doesn't rain, drought's going to sort of deepen. Places where it rains, it's going to beat back a little bit. But anything you want to provide for the drought context?
If we're thinking in terms of tracking, like with the drought monitor, I mean, you can remember going into last summer, we had severe and extreme drought across much of Arizona. One of the wettest monsoon seasons on record. Didn't completely erase the drought across the Southwest. So, we're not anywhere close to being on pace with 2021's monsoon as far as precip. So we're seeing, I think we're kind of nipping at improvements here and there. But unless there's sort of a really dramatic shift in August, and even if there is a dramatic shift in August with more widespread precipitation, I expect the longer term drought conditions are going to continue to persist. We're already, and we'll continue to talk about this the next couple of months, about this potentially third La Nina winter, which could be create further problems for the water situation, the snowpack, the longer term drought situation here in the Southwest.
Well, fortunately, the monsoon does not look like it'll be 2019 or 2020.
Yes. And it's like, even my really weak attempt to try to paint this as a bad monsoon, it's only bad because it hasn't rained in my house. If I got an inch of rain in the next couple of days, I'll be just perfectly happy.
All right. All right. Let's move on. Want to get to the monsoon fantasy so this is the point, Mike, in the podcast where we put you on the hook to give us your forecast for August going forward, and that sort of turns us toward the monsoon fantasy forecast game. Yeah, so this is our second iteration. We had quite a bit of turnout this year, Mike. I'm super excited about this. So this is our second running of the game. Thanks to everybody who signed up. But we've had 402 people provide at least a forecast or play in July and or August. And you can still make forecasts for August. So this 402 people is sort of a minimum estimate. So that is, a 33% increase from last year. We had a total of 296 people play last year. So I'm really excited about this. The other thing I'm excited about, Mike, is that, and we noted this last year, like we kind of came into this game and sort of wanted to tap into like all the weather enthusiasts in the region. We know there's quite a few of those people out there, people that listen to this podcast, for example, or rain loggers, but it turns out that a large fraction of the people who play this game, like self-describe themselves as sort of beginners or advanced beginners in their knowledge of weather and climate, which I am really happy about. I mean,
yeah, that's super cool. I mean, that's exactly what we were going for.
Yeah, we were hopeful to engage a different audience and see where that takes us. So 50% of the people self-identify as either an advanced beginner or a novice, which is great. In fact, the winner last year, I think, self-identified in one of those two categories. So you don't actually have to be an expert. And in fact, it's probably a detriment.
Thinking too much about your forecast is usually a problem, which is a bit counter to the science here.
All right. So what is your current standing? Do you know what your current standing is in point total?
I think I'm in the 50s right now.
Oh, really?
Way better than I have been in the past year.
I'm rolling in at 101.
Are you really?
Yeah, I'm in 101st place. So far, the leader goes by the name of Waterwise, and the points update each day. And so if more rainfall comes in these cities, the points can either go up or down. So as of right now, Waterwise has scored 27.36 points. I have scored 6.49. So there's a big there. Our own Ben McMahon is coming in at 5th place.
Dude, what's your name handle here? It wasn't very creative.
Ben McMahon has the most uncreative handle. So Mike, where are you? 50?
Clearly not in the top 10.
You're not in the top 20. All right. The other thing I want to talk about is we asked people what they thought the total precipitation of the monsoon season was going to be like. So just sort of a qualitative, much above average, near average, below average, or much below average. Do you think, Mike, we have a optimistic demographic, pessimistic, or sort of near average?
Okay, I'll give you my reasoning here. I think they're probably optimistic because if it's true with their demographics here, we've got kind of new interested people. They're not jaded yet. So that they're and I was the same way. I was an optimist, and it's slowly gotten beaten out of me over time.
That's interesting. We should look at their expectations of the season based on their self-identified expertise of the monsoon or knowledge of the monsoon. Right. We didn't do that. You are right, though. 60% of the people that played either thought this monsoon in aggregate was going to be much above average. 27% thought it was going to be around average, and only 12% thought it was going to be below average. Nobody thought it was going to be a disaster.
Nice.
Yeah. So kudos. It'll be interesting to see how this evolves over time. I mean, over the years, like whether or not, and recurrent players, like if that changes. These are just some fun things that we're playing with. So Mike, what do you think going forward? What's your August and September outlook? Mike and I have a side bet. We can't win, even if it doesn't look like we're gonna. Ben can't either, and he may. But we have our own sort of side bet, which is a few beers on the line. So, absolutely. And I actually always lose to you on this. So,
do you really? Are you sure?
I feel like it. All right. So your forecast for the rest of the monsoon, what do you think?
The official forecast coming out of the Climate Prediction Center continue to lean towards above average precipitation for certainly for the next month, and that shift is favored over kind of the core of the monsoon region. So it's Arizona and western New Mexico with the best chances over southeast Arizona, right? And that's been pretty consistent. So that's for August. If you look at the 6 to 10, the 8 to 14, and the week 3-4 forecast, all suggest that this enhanced monsoon activity will continue, right? So that's actually pretty encouraging. So that's at that sort of shorter time scale, reaches out through the end of next month. So what I did with my monsoon fantasy was go with just below median for all of the stations. It's a little bit below average for all of the stations. And it's mostly because if this is a persistent pattern, I think we're going to be lucky to squeeze out these average precipitation amounts at the stations in the game, even if the surrounding areas are actually getting kind of hammered with good precipitation. It's just a little bit gun shy with this July situation right now.
Yeah, so I was bullish in the beginning, and I waffled back and forth on this, right? Like on the one hand, it was like, we've had moisture around. Usually that wouldn't persist throughout the entire monsoon period. I would have thought in a situation like that we've had, that August might have less moisture around. And so I was sort of on the one hand leaning toward a dry forecast, but conversely, I was like, we just didn't squeeze it out as much as we could have. Consequently, I'm like, well, even if we have a little bit less moisture around, maybe the other parts of the puzzle are more favorable for water. So I was encouraged by the early onset, and I've been encouraged by the amount of moisture that's been around. And, I ultimately, sided with the optimist side. So I went for my August was bullish. Now, September is a different story, because I do think that the September gets into other kinds of mechanisms like decaying tropical storms that we have to take into account, and that with the La Nina event, or with the La Nina like conditions that sort of depressed tropical Pacific activity, I'm withholding my September forecast. But yeah, I'm ready to go on August. I hope it happens.
Yeah, me too. And August is so dicey because the monsoon can fall apart really fast. And that's what always makes me a little bit nervous about August, is like climatologically it peaks. It's this week and into next, and it kind of tails into the following week is kind of the peak of the season. And then it starts to wind down. And it's, it can be by August 15th that you're really starting to struggle to hold on to the good synoptic flow pattern. And then, by August 31st, you're really starting to, reach into the transition season as you're looking forward to September.
Let's see if Ben's able to turn on his mic. I'm curious what his expectations are, given that he's running fifth now. But, maybe you don't want to reveal your strategy.
Well, I'll tell you. I lean dry on this every time, just because, like Mike said, it's just so hard to get these things going that having 5 dry stations is a lot more likely than 5 wet stations. And if I try to guess which one's going to go dry, I feel like I'm going to get it wrong. So I just guess all of them dry and hope I hit on a couple of them.
Oh man, you cracked the code. That's actually
yeah, it's a statistical explanation and not a dynamical explanation.
It's not very exciting. Although I was trying to find, we plotted out a couple years ago, like the monthly total on a heat map, and to have a dry July and a dry August is pretty unlikely.
Yeah.
Right.
It hasn't happened very often. And it's not to say that there's some reason for that other than just chance. It makes me wonder if maybe I shouldn't be leaning a little wet on all of these this time around. So I'm rethinking it. I am rethinking it.
Mine already locked. They're not locked in, right? We can go back.
No,
not till
Okay. Man, oh man, I should.
You can make forecasts up until the clock turns to August 1st. So 11:59 on what is it, Saturday night? Or no, I have
Sunday night.
11:59 on Sunday night. I'll send out another email, but and you can still win the prizes if you miss 1 month and play for 2 months. So for those that didn't play in July, still get in the race, although WaterWise is making it really difficult. Last year, the winner won with a total of 35 points. So
Wow.
All right, Mike. I hope I hope this was a little bit of therapy for yourself, and you're less persnickety.
It always is. I do feel better kind of getting it out there. So thank you. Bill me what the going rate is on sort of climate therapy is.
Nice. We should start charging. And for those few that stuck around to the tail end, again, please do, if you can, donate 5 minutes, 10 minutes to answer the surveys in the show notes. But again, the URL is tinyurl.com/SW Climate Pod. All right, Mike, until August sometime.
Yes. Happy monsoon, Zach. May we both have an inch of rain at our houses in the next couple of weeks, which would even then be still below average.
If it's an inch by the next time, I'm still going to be grumpy.
I know, actually, I will be too. We should, 2 inches. Let's be a little more positive.
We need 4. That's average.
4 would be fantastic.
All right. Cheers, everybody. Thanks again.
Yeah.
Blah, blah. All right. While you work on that, we can move on.
Keep moving. I'll figure it out. I knew this morning, and I was in the 50s. I just wanted to make sure I didn't change.
Yes, you're right. I screwed up. The mean is to the right. We can cut that out then. Actually, I hope he leaves it in.